Welcome to the engineering mechanics. We'll continue our next part of the friction. Last class we have completed up to that what is frictional forces, what are the different factors affecting frictions. These are some basic ideas of the friction. Next we'll study another part. So what are the different types of friction? Okay. That classes we have studied static friction, kinetic friction, but we have to know what does it acting actually. So static friction and kinetic friction. So one here from this figure we see this applied force and the force of friction. Then where body is resting on a surface, here force of gravity is acting downwards, the weight of the body, and due to this weight one normal force is acting always in the opposite directions. So when the body is at rest, there are force of gravity and the normal force generated. Now when the body has to move in one direction, suppose in the forward direction, that is in the right hand direction, so here this is the force, applied force is given, and this is the force of friction. So if you see from the arrow mark itself, the applied force is more as compared to the force of friction. That means the body will be moving in this direction. But if applied force is equal to the force of friction, then the body will be at rest. Or if the force of friction is more than the applied force, still the body at that time also the body will be at rest. Now in this figure, if you see that force of friction and the applied force is equal, and normal force and force of gravity is always, that is the body will be in not motion, but here it will be, you see this one in the motion, it is written here. Now if you study the applied force in the static and the kinetic region, already I told you that static region means the force of friction when it acting and when the body is at that rest. Okay, so if you from the diagram, if you see when the force is applying, that the resistive frictional forces in the y direction, if you see, that is proportional to the applied forces. That means up to that point of region, static region, ending point of the static region, this applied force is directly proportional to the resistive frictional forces. So once it crosses that limit, that means applied force is more from this point, static region. When it enters the kinetic region, then the resistive frictional forces will be your less. Why it is? Because the body will be in the motion, so that means the opposing force will definitely less. So this part, static region part, is, if you see this here, the frictional forces is very high as compared to the kinetic region, the kinetic friction. Now as we all know how the friction is occurring in our daily day-to-day life activities, friction force is occurring, but considering our one of the most important phenomenon when a wheel is moving, okay, so whenever for to stop that vehicle, we require to apply brake, we need apply a brake. So we have to know, to stop when a body is moving at a certain velocity, what should be the braking distance, so that it will not collide with the objects in front of it without colliding in front of its object, so that the vehicle can be stopped. So for this we have to know the braking distance, and braking distance, it will be definitely, it will some impact of the friction. So how we have to consider that brake distance in relation to the friction? So the formula of the braking distance in case of that automobiles, you see it is equal to v square divided by twice g mu. Mu is the coefficient of friction between the tires and the roadway, and d is the your braking distance, g is the acceleration due to gravity, and v is the initial speed in meter per second. So from here, if you see, if velocity, that means if the initial velocity of the vehicle is very high, that you see that d will also be, because d is proportional to the square of the velocity. That means if the velocity is very high, then the braking distance will be very high. That means braking distance will be more. So that means when we have to brake at a high velocity, then the braking distance will be very high, and when the velocity is low, then braking distance will be low. So that means we can, if we are going at a high speed, we have to brake from a long distance, so that it will be brake easily without colliding the front objects. That means if anything is in front of this one, it will not collide with the one. So that means at low velocity we have to apply low brakes. That means the power of the brake also should be low. That means braking distance will be less. So why? Because it depends on the that moving velocity and the friction occurring between the tires and the roadway. Similarly, as we all know, in the straight road in the vehicle, we know that it is not difficult to move the vehicle because there is no car friend. So that means frictional forces, though it is acting, but it will be linear type. But when your vehicle is moving in the curve road, so what will be the friction in the curve roads? Okay, so for the maximum velocity, how we have to find out the maximum velocity of that vehicle or V max is given by equal square root of mu static into gr. Mu static is the coefficient of the static friction, V max is the maximum velocity, and g equal to acceleration, r is the radius of curvature. So if you know the maximum velocity of the curve road, then g acceleration, d gravity, and the radius of the curvature, you can easily find out the mu static. Or if it is given mu static is given, then r is also given, we can easily find the what is the maximum velocity, so that in the curve road, so the vehicle will move without any stoppage. So this is the V max, and from this relation we can find out r mu static V max if any of the two among these three, because g is already we know among three, V, mu, and g, if any of these two we can know, we can definitely find the other unknown data from these relations. Okay, thank you.